means clockwise. So see, tool cuts the material in clockwise direction. Trying to show you G00 movement. You only have to see whether tool is moving fastly or not with the help of G00 code. So it's moving fastly. G00 moves fastly and G01 code moves slowly. Our programming syllabus starts. So our 8th topic is G code. So what is G code? So it is preparatory function used to define operational condition. That means it's ABCD of programming language. So with the help of G codes, we can write a program and we can also instruct CNC machine that where to move, how to move and all. So all these we can do with the help of G codes. So let's see G codes. So these all are our G codes. If you Google G codes, then you will get so many G codes and they may confuse you. That's why I have created list of G codes, and with the help of these G codes, you can create or develop any program. So here I have listed all G codes. G00, G01, G02. So all codes are listed here. So let's learn all the G codes in detail. So our first code is G00. So whenever tool is not cutting any material, at that time we have to move that tool fastly. So as you can see here, from P1 to P2, tool is not cutting any material. So here during P1 to P2, we can move tool fastly. So here use G00 code. So remember, if tool is not cutting any material at that time, we have to move tool fastly. So let's see G00 code with the help of video. So here in this video, I have used G00 code and I am only trying to show you G00 movement. You only have to see whether tool is moving fastly or not with the help of G00 code. So it's moving fastly. Our next code is G01. So whenever tool is cutting material, at that time we have to use G01 code. So during actual cutting, we have to move tool slowly with the help of G01 code. And how slow it have to move is given with the help of feed. That means what will be the cutting speed of tool is given with the help of feed. So let's see G01 code with the help of video. So here I have used both G00 and G01 codes so that you can get difference between these two codes. That G00 move fastly and G01 code moves slowly. You can see it once again. And if you can see, I have given feed 0.4 after G01 code. So it's compulsory to give feed after G01 code. If you don't give feed after G01, then tool will move fastly and due to which there are chances of accidents. So always remember, give feed after G01 code. So here you have seen the difference between G00 and G01 code. So next code is G02 code. So if you want to cut material in clockwise direction, at that time use G02 code. And if you want to cut material in anti-clockwise direction, then use G03 code. Here we are going to see two conditions. If tool is going to cut material from upper side and second condition is from bottom side. Normally tool cuts material from upper side, but mostly in small CNC tools are arranged in front of each others on the same bench. So at that time you have to consider tool's direction. That means whether tool is coming from upper side or from bottom side. So if tool is coming from upper side, then the first radius that tool is going to cut is in anti-clockwise direction. That means that first radius is in anti-clockwise direction for tool which is coming from upper side. So use G03 which is for anti-clockwise direction. And second radius is in clockwise direction. So there we use G02 code. So this is for that tool which is coming from upper side. And if tool is coming from downside, at that time first radius that it will cut is in clockwise direction. And for clockwise we use G02 code. And second radius is in anti-clockwise direction. And for anti-clockwise we use G03 code. So you have to look this very carefully, that from where your tool is coming to cut the material. Whether tool is coming from upper side or from down side. So now let's see this with the help of video. So here I am using downside tool. And here I have used G02 code. So G02 means clockwise. So see. Tool cuts the material in clockwise direction. So now let's see G03, that means anti-clockwise cutting direction. So I have written G03 code in program. So see, tool cuts the material in anti-clockwise direction. So I hope you understand the difference. G02 is clockwise cutting direction and G03 is anti-clockwise cutting direction. So before using G02 and G03, look at the tool from where it is coming. And according to that, you have to use G02 and G03 code. Our next code is G04. It is dwell time. So if you have to stop the tool for some seconds, then you have to use this code. So for better surface finish, we stop tool for some seconds. So you have to write U after G04 code and then give how many seconds you want to hold that tool. So we want to stop tool for 2 seconds. So write G04 and then write U2. So machine will understand that it have to stop for 2 seconds. So let's see this with the help of video. So here I have written G04 code to stop machine for 2 seconds. So see, machine stops for 2 seconds and again starts running. So this is mostly used in drilling and grooving for better surface finish. Our next code is G20 and G21. G20 code is used for size in inches and G21 code is used for size in mm. That means if you want all your dimensions in inches, then use G20 code, and if you want all your dimensions in mm, then use G21 code. Here I have written one conversion formula. 1 inch is equal to 25.4 mm. So you have to know this conversion formula. Our next code is G28, G29 and G30 code. So as you know, G28 code is used for tool reference, that is for homing. But sometimes we have job with small operation like only chamfer or radius. So at that time, to take that tool to its home position and again call it to perform only that small chamfer or radius, So this will take much time. So at that time, create a new home position near job and make it as reference position and call that tool from that new reference position to perform that small operation. So this will save your time. So G29 and G30 are used to create new home position or new reference position for tool. So tool will stop there instead of going to its main reference position. So let's see this with the help of video so that you can understand much better. So firstly, we will see G28 reference position. So see, this is reference position for G28. Now remember this position. Now we will see G29 and G30 reference position. So I have created new reference positions here. So this is the reference position for G29. And this is reference position for G30. So here we have created two new reference positions. So with the help of this, we can reduce our cycle time. So if your job is having only one or two operations like chamfer or radius, at that time you can use G29 or G30 to create new reference position. But it's preferred to use G28 for reference tool. Our next code is G40, G41 and G42. So these are related to insert nose radius effects. We will see this insert nose radius effect in detail in our separate topic. So moving on, our next code is G50. So we have to tell our machine that what is the maximum spindle speed of our CNC machine. And above that spindle speed, our spindle will not have to move. So to tell that speed, we use G50 code. Here I have written G50 speed 2000. That means maximum speed of spindle is 2000 RPM. And above this speed, spindle will not able to rotate. So here we have created limit for spindle speed with the help of G50 code. So it is important to use this code in our program. If you don't use this code, spindle may rotate with very high speed and this may cause accident. So it's better to use this code as it will reduce machine vibrations as well as it will increase tool life. So always use this code in our program. I will tell you how to use this code in program in our standard format topic, but for now just remember that G50 code is limit of maximum speed of spindle. Our next code is G90, absolute mode. Now we will learn how to calculate coordinates with the help of this diagram. And here we will calculate coordinates with the help of absolute mode. So in absolute mode, we do calculations from job 0 point. Here our job 0 point is O. So by considering O as reference point, we will calculate all the coordinates. So this method is absolute method. So in this course, we are going to use this method. So let's see this method and let's find coordinates. So our first point is O. So O is our job 0 point. As we have created job 0 point during setting, so our coordinates of O are 0, 0. Now we will do calculations from this point. So A. What is X value for A? That means what is the diameter at point A? 28. So X is diameter, and as you can see at A we have 28 diameter. And what about Z? So there is no movement in Z. So our coordinates for point A are 28 and 0. That means x distance is 28 and z distance is 0 from O point. Now we will see B. So we will calculate coordinates at B from O as its absolute mode. So what x distance B have moved from O? So as we know, x is diameter. So 28 diameter B have moved from O. And how much z distance B moved from O? So it's minus 70. As it's moved in left side in z, so it's minus. So our B coordinates are 28 and minus 70. X is 28 and z is minus 70. Now we will move towards C. So diameter in C is 32 and z distance from O is minus 70. So coordinates of C are 32 and minus 70. Now let's see D's coordinates. So x in D, that means diameter at D is 32. And how far our D from O in Z direction? So it's 70 plus 80, which is 150. So minus 150 mm. So coordinates of D are 32 and minus 150. X is 32 and Z is minus 150. So this is how we have to calculate coordinates with the help of absolute mode. So I hope you understand this absolute mode. So now let's see increment mode. And for this we use G91 code. And in this mode, preceding point is considered while calculating coordinates. So here coordinates of O will be same. This is 0, 0. What about A? So A have 28 diameter from O. So x at A is 28. And how far A move from O in Z direction? So A have not moved any distance in Z from O. So Z coordinate is 0. So our coordinates of A are 28 and 0. Now let's see B. So how far B travel in x from A? So B have not traveled any distance in x from A. So x coordinate of B is 0 as B and A are on same diameter. So in increment mode, we consider preceding point, not O. Okay. And how much z distance B travel from A? So it's minus 70. So coordinates of B are 0 and minus 70. Now let's see C. So how far C move in x from B? That means how much diameter C move from B? So it's total 4 diameter. And C do not move any distance in Z from B. So Z is 0. So coordinates of C are 4 and 0. Now let's see D. So how much distance D move in x from C? As you can see, D have not moved any distance in diameter from C. So x coordinate of D is 0. And how far D move from C in Z direction? So in Z, D move minus 80 from C. So Z coordinates are minus 80. So coordinates of D are 0 and minus 80. So this is our increment mode. So you can use any one mode from absolute or increment to calculate coordinates. Here in this course, I am going to use absolute mode as it's easy to understand and it is with very less confusion than increment method. But you can use any one from these two methods. So our next code is G95. It is feed unit. So with the help of G95, we will tell CNC machine that our feed is in mm per revolution. That means in one revolution, how much distance tool have to move is given with the help of feed. And for this we use G95 code. So this G95 code is mainly used in turning, that is in CNC turning, which is feed in mm per revolution. Our next code is G96 and G97. So as we know, as diameter changes, spindle speed also changes. So if you want all these speed calculations to be done by CNC itself, then you have to use this G96 code. So if diameter of job is changing, then you have to use G96 code along with cutting speed. How to calculate this cutting speed is we are going to see, but for now just remember you have to give G96 code along with cutting speed. So if you want all these speed calculations to be done by CNC itself, so you have to use G96 code along with cutting speed, so that CNC machine will understand that diameter is changing in workpiece, and according to that CNC will do its calculation. So this is G96 code. You have to write G96 code along with cutting speed. And if workpiece is not having any diameter change, at that time you have to use G97 code. So with the help of G97 code, machine will understand that there is no diameter change in workpiece. So machine will not change its spindle speed. So you have to write G97 code along with spindle speed that you want to give to your spindle. If you give 1500, then spindle will rotate with 1500 speed. So G97 is for fixed RPM. But in G96, spindle speed will change according to diameter of the job. And in G97, you have to give speed which is fixed for that workpiece. So these are our G codes. So with the help of these G codes, you can make program of any job. So you have to remember these G codes. So here we have completed our G codes.
These are premium educational videos that are usually paid, but I'm sharing them for free on YouTube. Subscribe and support the channel.